Control structures allow a programmer to define how and when certain statements will be executed. The most popular control structures are loops and if-then statements. Both allow to add complex functionality to your methods in a flexible and maintainable way. In this chapter, we will provide extensive coverage on how to control the flow of your program. Let's start with the overview. We will first provide a short recap of comparison operators and methods. Both are frequently used in control structures, which are discussed next. More specifically, we will zoom into if-then statements, for loops, while loops, and switches. The chapter concludes by reviewing some additional keywords to further control the flow of your program, such as return, break, and continue. Let's get started. Comparison operators and methods have already been discussed in Chapter 2. Remember, for primitive data types such as int, long, double, etc., you can make use of relational operators to verify if one operand is bigger, bigger than or equal, lesser, lesser than or equal, equal or not equal to another operand. The result of these operators is a Boolean, so either true or false. Logical operators can be used to combine multiple Boolean statements. The most popular are AND, OR, XOR, and NOT, whereby the latter only uses one operand, remember? In case of composite data types, comparison operators must be explicitly defined in the class definition. One example are strings, which you will often need to compare as you start developing your Java programs. The string class implements a method called equals, which allows you to do this. Here, you can see this illustrated. You can see 3 strings defined. The method equals verifies whether the content of 2 strings is equal, yes, or not. Very important to note here is the difference between the double equals operator and the equals method. The double equals operator will check whether 2 objects are the same. In other words, whether they have the same position in memory. The equals method can be used to check whether 2 strings or arrays have the same content. It can thus be that 2 strings have the same content but are different objects and thus located at different positions in memory. We can now use the comparison operators in our control structures. In this section, we will teach you how to create if-then statements, for loops, and while loops. We will also compare both for and while loops. We finish by discussing switches, which are an interesting alternative to if-then statements. An if-then statement allows you to conditionally execute a set of statements. In other words, depending upon a pre-specified condition, a set of statements is executed. It is also referred to as branching. Here, you can see some examples listed. If account balance is bigger than 100, then a message is displayed on the console saying save balance. If account balance is not bigger than 100, nothing will happen. We can also add an else keyword as the next example illustrates. If account balance is bigger than 100, then display save balance, else display warning low balance. The else keyword can be followed by a second if statement as shown in the third example. Suppose the balance is 80. What message will be displayed here? Well, you can just follow the branches of the if statements and you will see that the message printed is warning, low balance. Control structures such as if-then statements can also be nested. This allows you to very precisely define the flow of your program. In this example, you can see 3 if-then statements nested. To facilitate the readability of your code, it is recommended to vertically align the closing bracket with the F keyword it closes, as you can see illustrated. Here, we will first check whether the account balance is bigger than 0. If yes, a message will be printed saying save balance. Next, we will check if the account has been active for more than 90 days. If this is also true, then an offer to open a savings account will be printed. If the number of credit accounts is bigger than 1, then the balance transfer possible variable is set to true. If the number of credit accounts is not bigger than 1, the method send credit application is invoked. This closes the inner if-then statement and brings us one level higher. If account days is lesser than or equal to 90, nothing special happens. This closes the second inner if-then block and brings us to the outer if-then statement. If account balance is less than or equal to 0, the message alert negative balance will be printed. Our previous example can also be programmed alternatively by using Boolean operators and multiple if-else-if statements, as you can see illustrated here. Remember, the double ampersand symbol implements the logical AND operator. This code is perfectly equivalent to the previous code, but you can see duplication of statements such as system.out.println save balance, which is included 3 times, and system.out.println savings account offer, which is included 2 times. Hence, this option will complicate the maintenance of your code, and it is thus recommended to use nested if-then statements instead. A next important control structure is a for loop. A loop allows you to cycle through a set of code statements as long as some condition is met. In other words, it allows repetitive execution without repetitive coding. You can see the standard syntax of a for loop here. It has 3 key components: initialization, termination, and increment. The initialization declares an index variable for the for loop and sets its starting value. Commonly, this will be integer I set to 0. The termination specifies the stopping condition or maximum value for the index. The increment indicates how the index value should change after each iteration or step of the loop. Commonly, this will be I++, which means that the value of I will increase by 1 after each loop. The loop statements themselves are then put between curly brackets. Let's discuss some examples. Here you can see 3 arrays of integers defined. The first array, sales 2014, contains the sales numbers during each month of 2014. The second array, staff 2014, contains the amount of staff during each month of 2014. The third array, sales per staff, is an array of 12 integers which needs to be computed by our program. We also define an integer variable total sales 2014, representing the total sales of 2014 and initialize it to 0. We now define a for loop. The index variable I is initialized to 0. The termination criterion is I is strictly less than sales 2014.length, and I is increased with 1 unit each time at the end of a loop step. Question: why is the termination criterion I is strictly less than sales 2014.length and not less than or equal? Well, the length of the array is 12, but the first element is stored at index 0 and the final element at index 11. So we need to use strictly less than and not less than or equal. Two things happen during each step of the for loop. First, we calculate sales per staff I as the division of sales 2014 I by staff 2014 I. This allows us to calculate the sales per staff for each month. Next, we update total sales 2014 as total sales 2014 plus sales 2014 I, hereby accumulating the total amount of sales during the year 2014. Working with loops, as illustrated here, is very flexible and maintainable. Imagine that sales are recorded weekly instead of monthly. The three arrays will now have 52 elements instead of 12. What would have to happen to the for loop then? Indeed, nothing. It can continue to be used as is. Here you can see two other examples of for loops. What do you think will happen if we run the first for loop? Actually, the loop will never end. The index variable I is initialized to 5 and increased each time with 1 unit at the end of a loop step. The termination criterion says that the loop should continue as long as I is bigger than 0 or positive, but since this continues to be the case for each loop step, the loop will never end and we have an infinite loop. What does the second for loop do? Well, it starts at I equals 1 as long as I is less than or equal to 10 or 5 in this case. Let me do that again. Well, it starts at I equals 1 as long as I is less than or equal to 5, incrementing I each time at the end of the loop step. It will calculate the double of I and print out the value of I together with its doubled value. Once the loop is completed, a message, end of program, will also be displayed on the console. Here you can see the output of both of our previous for loops. I can advise you to play a bit with these loops in Eclipse. You can do this by changing the initialization, termination, and increment statements. Then first carefully think what will happen, and then verify this by running the statements in Eclipse. An enhanced for loop is an alternative for loop introduced specifically for arrays and other iterable objects. It makes use of an iterator which automatically iterates without requiring initialization, termination, or increment. Here you can see two examples. The first one is our previous example, but now with an enhanced for loop instead. It can basically be read as follows. For each integer in the sales 2014 array, perform the two calculations specified. Our second example makes use of an array of strings. Here, the enhanced for loop reads, for each string in the name list array, print that string. As you can see, enhanced for loops are easy to code and read. Just as if-then statements, for loops can also be nested. Assume we have a matrix representing the number of hours an employee worked during each day of the week. For example, employee Bart worked 2 hours on Tuesday. For each employee, we would like to know the total number of hours worked and use that to calculate the weekly pay. First, we define our matrix, or two-dimensional array, hours worked. What do you think the value of hours worked evaluated at indices 1 and 3 represents? Indeed, it refers to the hours Seppo worked on Thursday, which is 4. We then define an array employees with the 3 names as strings. The wage is a double initialized to 8.30. Our first, or outer for loop, iterates over all employees. We print out the name of the employee together with the string worked and initialize the weekly hours variable to 0. For a given employee I, the inner loop iterates over all days of the week, hereby counting the weekly hours the employee worked. Note that in this inner loop, we'll refer to the index variable I, which was defined in the outer loop. The weekly hours variable is then printed together with the wage per hour. Next, the weekly pay is calculated as weekly hours times wage and also printed. Here you can see the output of our code. Again, I recommend to play a bit with the initialization, termination, and increment statements of both for loops, carefully think what will happen, and then verify in Eclipse. A while loop is an alternative loop structure that is based on meeting a certain condition instead of iterating a set number of times. You can see the syntax displayed here together with a small example. In the latter, you can see an integer variable I initialized to 5. The while loop then first verifies if the condition is true. Obviously, 5 is bigger than 0, so the loop is entered. First, the value of I is displayed to the console. Then, it is decreased with 1 unit and the loop starts again until the condition is no longer satisfied. In other words, the output of this while loop will be the values 5, 4, 3, 2, and 1. Here you can see our two earlier examples, but now implemented using while instead of for loops. The first example is again an infinite loop. The reason is because the variable I is not adjusted in the loop, and since it was initialized to 5, it will keep this value and thus continue to be positive always. In the second example, we start from I equal to 1. As long as I is less than or equal to 5, we calculate its double value, and print both I and its double value to the console. We then increase I with 1 unit and continue with the loop until the condition is no longer satisfied. Once the while loop has finished, the message "End of program" is printed. A do-while loop is an alternative form of a while loop. As opposed to a while loop, a do-while loop will first execute the loop statements and then the conditional expression to see if the loop should be repeated. Its syntax is given here, together with an example similar to the one we discussed when introducing the while loop. We start by initializing I to 5. Without evaluating any condition, the loop statements are executed. The value of I is printed and decreased with 1 unit. Then, the loop condition I bigger than 0 is evaluated and the loop repeated until the condition evaluates to false. A do-while loop can be useful when you want to ensure the statements in the loop are executed at least the first time. Here you can see the example we discussed earlier using a do-while loop. We first set I to 1 and then enter the loop. We double it and print its original value together with the doubled value. In the next step, I is increased with 1 unit. The loop concludes by verifying the condition I less than or equal to 5 and continues. A message is displayed once the loop has finished. Again, I strongly advise you to play a bit with this loop in Eclipse to make sure you fully understand its functioning. It is clear by now that for, while, and do-while loops can often be used interchangeably. In other words, for most problems, we can use the loop structure we feel most comfortable with. However, as we will discuss later, some specific problems will require a specific loop structure. Some general guidelines are as follows. If you iterate over a collection, consider a for loop first. If you know the number of loops in advance, consider a for loop first. If you don't know the number of iterations, but the number depends on a certain condition, consider a while loop first. Switches provide an alternative to if-then statements. They are particularly useful when you have several else clauses. A switch statement evaluates a single variable and, depending upon its value, executes a certain block of code. Here you can see the syntax of a switch statement. Each case is labeled with one possible value the variable might take. If the label matches the value of the variable, the statement that follows the column for that case will be executed. Cases are evaluated sequentially, from top to bottom. Once a match is found, all the statements to follow will be executed, even those intended for the other cases that follow. To prevent this from happening, the break keyword is used. Its purpose is to break out of the switch and continue with the rest of the program. If none of the explicit cases apply to the variable, default will still apply. This can be useful to handle unexpected situations. Let's present some examples. Here you can see an example with a string. We have a string variable, my name, which is set to Bob. The switch statement evaluates the variable my name and, depending upon its value, sets the initial. For Bob, this will be B, as you can see. Note that also a default is provided in case no match can be found. This is another example. The goal is to determine the last day of each month. In other words, January has 31 days, February 28 or 29, depending upon whether it's a leap year, etc. The month variable represents the switch variable, and the last day variable represents the number of days in a specific month. Again, note that a default case is also provided. The switch can be further simplified since many of the cases result in the same outcome. Here you can see the simplified version. It is obtained by lumping the months or cases together to treat them identically. In this example, we apply a switch to a loan type variable to decide upon the interest rate. You can see that it is self-explanatory. As with for and while loops, switches can often be used interchangeably with if-then statements. Some general guidelines are as follows. If you have a single variable that can take multiple values, a switch might be suitable. If you have multiple variables or conditions to consider, you will probably need an if-then statement. If the variable you are considering can have a finite number of values, consider using a switch. If the variable can take any value within a continuous range of numbers, consider an if-then statement. To conclude this chapter, we will discuss 3 keywords which can be used to interrupt the execution of the current block of code. The difference among them is found in what happens after the interruption. The return keyword enforces a hard interruption. In other words, it completes the execution of a method and returns a value. The break keyword provides a softer interruption. It interrupts the execution of the current block of code, but the method execution continues. We already illustrated this with the switch statement. Finally, the continue keyword is the softest interruption. It stops the current iteration of the loop and continues with the next iteration. Let's give some examples. Here you can see the return keyword illustrated. The variable employees represents an array of employee IDs coded as strings. The method findEmployee searches for a specific employee ID, which is given as its input argument. It uses an enhanced for loop to iterate through the employees array. If a match is found, it returns true, which means the for loop and method are ended and the result true is returned to the caller. In case no match is found, the method will return false. This is another example of using the return keyword. The variable employee list is an array list of strings. The method addNewEmployee takes the employee ID as its input variable. If the employee is found in the array list, then there is no need to put him or her into it. Therefore, the code returns nothing as soon as the employee is found and then exits the method. In case the employee is not found, he or she can be added to the list. Here you can see the break keyword illustrated. We again start from the variable employees, which is an array of employee IDs represented as strings. The method findEmployee searches for a specific employee specified by the input argument employee ID. It initializes the myString variable to employee ID not found. It then starts an enhanced for loop iterating through the employees array. If a match is found, the myString variable will be overwritten and the break statement will stop the loop and continue the method execution. If no match is found, the loop will end as usually and the myString variable will keep its original value. In both cases, the myString variable will be printed to the console. The continue keyword is the softest interruption, as you can see illustrated here. The array all employees is an array of employee objects. Each employee object has a method isManagedBy to check if an ID value refers to the manager of that employee. The method printManagedBy will loop through all employee objects. If the current employee is not managed by the ID specified, the current iteration will stop and the next employee will be checked. If the current employee is managed by the ID, the loop will continue to the print statement before proceeding to the next iteration. Both the break and continue keywords can be combined with a label in order to control the flow even more directly. Here, you can see an example of this. We have two nested for loops. A label is defined by a name followed by a column. Here, we defined a label outer corresponding to the outer for loop. In the inner for loop, the if-then statement will verify whether the sum of both loop variables I and j equals 3. If yes, the break outer statement will break out of both for loops. Note that if we would not have included the outer label, the break statement would only break the inner loop. To conclude, in this chapter we started by reviewing comparisons using both operators and methods. We then discussed various methods for language control, such as if-then statements, for, while, and do-while loops, and switches. We also elaborated on keywords to further refine control, such as return, break, and continue. The concepts presented here will be used throughout the remainder of this course.